In this video, I'm going to go over the study guide for the performance exam that we're having this semester. So first of all, in the figure, it says A is parallel to B, and that angle 1 is 35, angle 2 is 80. So we're going to go ahead and I'm going to label these as parallel first, because just that helps me know that there are some angles then that exist. It tells me that angle 1 is 35, and that angle 2 is 80. And then it asks me about angle 3. Well, the way I'm going to get angle 3 is I'm going to do 35 plus 80, and I'm actually going to subtract that from 180. And the reason I'm doing that is because a line is 180 degrees, and line A is what I get to when I add 1, 2, and 3. So I'm actually doing the angle addition postulate there, and it's because the line measures 180 degrees. So when I do this, I get that angle 3 is 65 degrees. And then angle 4. So this was 65 degrees. So that means angle 4 would be 65 degrees because it's a vertical angle to angle 3. So that's 65 degrees. And again, I would say angle addition postulate here. And here, vertical angles. All right, so with number 5, it's again another vertical angle to 2, so we're going to say that it's 80 degrees. So this is 80 degrees. So we're going to say angle 5 is congruent to angle, I'll do it this way. Angle 5 is congruent to angle 2. Again, vertical angles. And up here we had for 4, that angle 3 was congruent to angle 4. So number 6 is a vertical angle to 1, so we could say again, angle 1 is congruent to angle 6, vertical angles again. So this one's going to be 35 as well. Then we have angle 7. I noticed that angle 7 and angle 4 are supplementary because they're same side interior. So I could say that angle 4, the measure of angle 4 plus the measure of angle 7 equals 180 because they're same side interior angles. So 4 was 65, so we're going to subtract 65 from 180, and that's going to give us 115 for the measure of angle 7. Well, I also know that that would be the measure of angle 12 because, again, angle 7 is congruent to angle 12 because of the vertical angles, congruence theorem. Vertical angles, okay? So this is going to be 115 as well. And when I look at 8, if I have 7, 7 and 8 are a linear pair. So I should know that the measure of angle 7 plus the measure of angle 8 equals 180. That's because they are a linear pair. And so I'm just going to subtract 115 from 180, and that's going to give me 65 here. And we know that if 8 is 65, that 11 is 65. So angle 8 is congruent with angle 11, again, because they're vertical angles. So this is also 65. And then over here with 10, we're going to go with 10 first because I think that's going to be easier. So again, I see same side interior angles. So the measure of angle 6 plus the measure of angle 10 is equal to 180, again, because they're same side interior angles. So I'm going to subtract 35 from 180, and that's going to give me 145. So this angle right here is 145, which also means that obviously that 13 is 145 because, again, they're vertical angles. So here again we can say that angle 10 is congruent with angle 13, vertical angles again. I'm going to write out the word this time. So that is also 145. And then we have 9, and again, 9 and 10 are a linear pair. So I could say that the measure of angle 9 plus the measure of angle 10 is equal to 180 because the line measures 180 degrees. So I'm going to subtract 145 from 180, and that gives me 35 degrees for angle 9. So this is 35 degrees. And again, this was because these were a linear pair. And then I think we have 14, right? That's the only one that's left. Again, we have vertical angles here. So angle 9 is congruent to angle 14 because they're vertical angles. So that means that it's also 35 degrees. So here's all of this written out all nice and pretty, typed up so you guys can read it very clearly. And then when we go to part B, it says, what are all the pairs of the following angles in the diagram above? Corresponding angles are on the same side of the transversal. So I'm going to write that here. Same side of parallel lines and the same side of the transversal. Sorry. So when we talk about those, we've got like 1 and 9. If we look up here at the drawing, let me move this. Notice they're on the same side, top of the parallel line, and to the left of the transversal. We've got 3 and 8. So see 3 and 8 here again on top of the parallel lines and to the right of the transversal. Then we've got 4 and 11. 4 and 11 are on the bottom of the parallel lines and on the left of the transversal. And we have 6 and 14 are on the bottom of the parallel line and on the right of the transversal. Alternate interior angles are angles that lie on alternate sides of the transversal. So here we've got 4 and 8. Notice they're congruent. And then we've got 35. We've got 6 and 9. They're on alternate sides of the transversal, and they're inside the parallel lines. That's what interior means. Alternate exterior, we've got 1 and 14 here. Again, different sides. That's what alternate means of the transversal and outside the lines. And then we've got, if you notice here, we've got also 3 and 11. 3 is over here and 11's over there. So they're on opposite sides, alternate sides of the transversal and outside the parallel lines. Then we have same side interior. We already talked about this. 4 and 7 and 6 and 10 are same side interior on the same side of the transversal and inside. We got lots of vertical angles here. So we talked about this a lot too. So we've got 1 and 6, 2 and 5, 3 and 4, 7 and 12, 8 and 11, 9 and 14, 10 and 13. And then we have a bunch of linear pairs as well. So basically we've got 7 and 8, 8 and 12, 12 and 11, 11 and 7, 9 and 10, 10 and 14, 14 and 13, 9 and 13. Those are all our linear pairs. Down here for the last part, basically all you need to do when you get down here to this bottom part is the explanation that we did up here. You're just going to write it out down there and then tell me exactly what you did mathematically as well. So for number 2, it says plot the preimage. That's our QRS. It's in QRST. It's in black. And then it says dilate the image by a scale factor of 1/2. That means we're going to multiply 1/2 times all of these numbers. So we're going to go 1/2 of 2, 1/2 of 4, 1/2 of 4, 1/2 of 4, 1/2 of 4, 1/2 of -6, and 1/2 of 2, 1/2 of -6. When we do that, we get these transform points, Q prime, R prime, S prime, T prime. We go ahead and plot those, and you will notice that this is 1 wide up here, whereas that was 2 wide. And this is also half as big, so it was 8 tall, and now it's 4 tall. And that's what it should be if it dilated by a scale factor of 1/2. And then part B says translate the vector by the vector, translate the rectangle QRST prime, 1 unit left and 2 units up. So we're going to subtract 1 from every x value, and we're going to add 2 to every y value. When we do that, we get our QRST prime, double prime, basically. And we would then plot those 4 points and label them Q prime, R, Q double prime, R double prime, S double prime, T double prime. And you know, let me get rid of this. It's coming with us. And so then it's asking us for part C. Is rectangle QRST congruent to rectangle QRST double prime? The answer is no, because it was dilated. If it had only been translated, yes. But because it's dilated, no. All right, so this next one. Again, we're going to plot JKLM. That was my black one right here, JKLM. Then it says graph the image of the rectangle JKLM after a reflection over the x-axis. So that rule is x negative y, so we're just going to change the signs of all our y's. So this was -4, it becomes +4. This was -1, it becomes +1. This was -1, it becomes +1. This was -4, it becomes 4. Plot those points. That's my JKLM prime up here. And I can see that it is a perfect reflection over the x-axis. Part B says translate the rectangle JKLM prime 3 units right and 2 units down. So we're going to take this red one and we're going to go 3 to the right and 2 down. And every point we're going to add 3 to the x's and subtract 2 to the y's. So that's what I did here. So I took my -6 and I added 3 to it. I took my 4 and I subtracted 2 from it. I'm going to do that with every point to get my JKLM double prime. So this one now, part C says, again, is rectangle JKLM congruent to rectangle JKLM double prime? And the answer here is yes, because a reflection produces a congruent image and then a translation produces a congruent image. All right, so down here for the last one, part A, we're going to plot A, B, C, D down here. That's our black one up here. Then it says graph the image of rectangle ABCD after a rotation of 90 degrees clockwise. Notice that word right there, clockwise. This is not counterclockwise like we learned. So counterclockwise, a 90-degree clockwise rotation is a 270 degrees counterclockwise rotation. So that rule is y. Remember, if it's 90 or 270, we flip the x and y. So that's going to be y negative x. So if we're in quadrant 1, this took us all the way to quadrant 4, sorry. So then when we apply that rule, we put the x where the y was, the y where the x is, and we change the sign of the x. Change the sign, change the sign, change the sign. Go ahead and plot that one, ABCD prime. Then it says we're going to translate ABCD prime 2 units left and 2 units down. So again, 2 units left means we're going to subtract 2, and 2 units down means we're going to subtract 2. So subtracting 2 from the x, subtracting 2 from that 1 up there, subtracting 2 from that -1, subtracting 2 from the 1 here, subtracting 2 from the -6. So keep going through that process here. We get our ABCD double prime. Then it asks us for part C. Is rectangle ABCD congruent to rectangle ABCD prime? The answer here again is yes. Because a rotation and translation produce an image that's the same size and shape, right, as the original image. So the only time it's going to be no is if we have a dilation, okay? All right, let's move on to the next section. Okay, for this next section, it says a lifeguard is standing at point B. He's 50 feet away from the shoreline, A, and 30 feet away from the lifeguard tower, E. The lifeguard looks across the water and sees a swimmer at H and a shark at C. How far is the swimmer from the shark? Okay, so the first thing that I notice when I look at this drawing is that AB is congruent with AH. So I'm going to say AB is congruent with AH. I also notice that AC is congruent with AE. AC is congruent with AE. And I know that this angle right here is congruent with this angle. So I know angle BAE is congruent with angle HAC because they're vertical angles, right? So I can tell that these two triangles are congruent. So I can say that triangle ABE is congruent with triangle AHC by side angle side. So that means then that BE, segment BE, notice my two letters here, last two letters right there, BE, is congruent with HC. So that means if this is 30, then this up here has to be 30. That's how far the swimmer was from the shark. Part B says a town A and town B need to have a road built to get from one to the other. A bridge can be built over the lake or a road around the lake through point E. The road intersects point E. The line joining the town A to town B is parallel to the line joining C and D. So that last statement is the first thing I'm going to mark on this. So it says the line joining A to B and C to D is parallel. So I'm going to go ahead and draw a parallel symbol right here and here, because that's going to be relevant as we work through this problem. So we're going to say that DC is parallel to BA. So when we say that, then we can start talking about some angles, right? So notice that DB is a transversal, right? Does everybody notice that? I'm talking about the line from here to down here, okay? So that means this angle up here and this angle down here are congruent, right? So we could say that angle CDE, is congruent to angle ABE by alternate interior angles theorem, right? Y'all remember this? Also, we could say that about C and A, right? Angle C and A. But we could also talk about this angle right here, these angles. Y'all see that? So we could say that the vertical angles are congruent. So we could say that angle DEC is congruent to angle BEA, because they're vertical angles, right? Could have also talked about angle C and angle A, because they're alternate interior angles as well. Either way, we know that these two triangles are similar because, okay, let me put two arcs here, by the way, so we don't get confused. We know that these two triangles are similar because of angle, right? So we have two angles that are congruent in one triangle, two angles in another triangle. So what we want to do is write a similarity statement. So we're going to say that triangle EDC is similar to triangle EBA. And E was that congruent angle, right? And this was supposed to be a D, y'all. Not a very good D. All right. So then we can then start talking about sides that relate to each other, right? So if we look at, let's look at AE. So what does AE compare with in our statement? AE compares with CE. Y'all see that? AE and CE. So we could say AE over CE, right? That would be 12.6 over, or we could put it, you know what, let's put it the way it is in the problem. How about that? Let's go CE over AE. That's the way it looks in the problem, right? Little triangle over the big triangle, right? So we did AE over CE, or CE. CE over AE. Same thing, but we just flipped it. All right, so that's going to be 3.2 over 12.6, right? We could do that with another pair of sides too. It doesn't really matter which one we do. But now we want to be able to find the distance AB. So I want to be able to find this distance right here, from here to here. So that means I want the corresponding side to AB. So when I look at that, AB was going to go on the bottom. So we're going to put AB here because our big triangle was on the bottom. So now we got those two letters there, last two letters. So that's going to be CD. So CD up there was 3 miles, right? So, or actually 5 miles, sorry. So we've got CD 5 miles, and then we don't know AB. So what are we going to do with these two proportions, or these two ratios? We're going to set them equal to each other. So we're going to do 3.2 over 12.6 is equal to 5 over AB. We're going to cross multiply, so that's going to be 5 times 12.6 is equal to 3.2 times AB. And then we get 3.2 AB is equal to 63. So this is 63 is equal to 3.2 AB. So AB is equal to 19.7 miles. Okay, so that means this down here is 19.7. Then we're going to do the same thing for the other side. So we're going to find EB now. So when we do that, again, we're going to use our same ratio, 3.2 over 12.6. We're going to set that equal to, again, the missing part. So we want to find EB, so we're going to put EB down here. And what does it map to over here again? EB were the first two letters, so we're looking for the first two letters. They are ED. So ED in our statement is 3 miles. So here again, we're going to cross multiply. So we got 3.2 times EB is equal to 12.6 times 3. So that's going to be 3.2 EB is equal to, what did I get here? 37.8. Then we're going to divide both sides by 3.2. So EB is equal to 11.8. So this is going to be 11.8. So this is the triangle proportionality theorem, but which we use to solve for this problem. Okay. So part C says, or part 3, sorry, says, determine the distance between the towns A and B, round to the 10th. So we already did that. That was our 19.7 miles. And you could have done the work in there. And then it says determine the distance from town A to town B around the lake through point E. So if we're talking about that, determine the distance from town A to town B around the lake. When we do that, we're going to add together our 12.6 and our 9.7. So, sorry, 12.6 and our 11. So that's going this way, y'all, if we go around the lake versus across. So this would be where we would have built the bridge right here. That's 19.7, right? If we were to build a bridge, right? So the other one is going to be 12.6 plus 11.8, and that's 24.4 miles. Okay. Then it says part 3. If the cost, hold on a second, let me scroll down. Hold on. If it costs 4.1 million per mile to build a road around the lake and 5.6 million per mile to build a bridge over the lake, which would be cheaper to build? So obviously we're going to multiply. So if we talk about over the lake, which is a bridge, right? We're talking about 19.7 times 5.6. That would be 110.32 million, right? Okay. And then if we're talking about around the lake, we're going to do our 24.4 times 4.1. So this is going to be 100 million.04. So obviously the one that's cheaper is around the lake. So this one would be the one that's cheaper. That's our answer. So this last part is unit 4. It says in parallelogram JKLM, LM is 2x plus 5 and KJ is 4x. So we know that LM is congruent with KJ because they're opposite sides. We know that KL and JM. We also know that the diagonals bisect each other. So I'm marking all that stuff, okay? So I'm going to go ahead and answer A, and then we'll go on to the angles afterwards. So we know that LM is equal to KJ. So I'm going to set that up that way and solve it. So I've got 2x plus 5 is equal to 4x minus 15. I'm going to subtract 2x from both sides. That gives me 2x over here. I'm going to add 15 to both sides. That gives me 20. So x is equal to 10. Then it tells me I'm looking for LM, so I got to plug 10 back into LM. So LM is equal to 2 times 10 plus 5. So LM is equal to 25. And the reason this is true is because opposite sides are congruent. Okay. So the next one talks about Km. Km, it says find Km and justify the answer using the properties of parallelograms. So Km is the whole diagonal. Well, it looks to me like I've got KO here and I've got OM. Well, KO and OM are congruent according to my diagram. So what I'm going to do is I'm going to go ahead and I'm going to set those equal to each other. So I know that KO is equal to OM. And the reason that's true is because diagonals bisect each other. Then we're going to work the problem, right? So we're going to say 3y minus 3 is equal to 2y plus 3. Going to subtract 2y from both sides. That gives me y. And then we're going to add the 3 to both sides. That gives me 6. So now I can actually add these together to get my answer, right? So because I know that Km is equal to KO plus OM. So that's equal to 3 times 6 minus 3 plus 2 times 6 plus 3. So that looks like it's going to, these 3's are going to cancel each other out. So that's going to be 18 plus 12, which is 30. So Km is equal to 30. Okay, now we're going to go on to our angles, and I'm going to go ahead and start writing the angle measures into this drawing. So it tells me that LMJ is, so LMJ, that's this angle out here. This is 140, which means its opposite angle is 140 up here. It tells me that LJM, this angle right here is 15, which means this angle up here is 15 because they're alternate interior angles to each other. And then JMK is this angle right here. This is 60 degrees, which means this one up here is 60 because, again, they're alternate interior angles. So now I can subtract 60 from 140 to get this one. So this is be 80. And same way up here, 80. Now I could find all of this angle out here because consecutive angles are supplementary. So I could subtract 140 from 180. So that means this angle out here is 40, which means this opposite angle up here is 40. And then I could subtract 15 from 40. That would get me 25 here and 25 here. And then I could use the triangle sum theorem to find out the angles at O. So if I add 15 to 60, that's 75. Subtract 75 from 180, that's 105. And then I've got vertical angles right here, 105 and 105. And then I've got a linear pair there. So, or I could use triangle sum. Either way, there's 80 plus 25 is 105. And we subtract that from 180. That would give me 75 here. And this would give me 75 here. Okay, so I'm going to take you to the next page and I'm going to show you guys what I wrote. So when I look at angle LJK, that's LJK, that's that 25-degree angle right there. It says consecutive angles are supplementary. That's how I got the 40 out here. So I subtracted the 40 from, I basically add these two together, set them equal to 180. That's how I got 40. And then I do the angle addition postulate. I have to add those two angles together to get 40. So I subtract 15 from 40 to get 25. So that's the angle addition postulate. The next one, part D, says find the measure of JKM. So JKM is this angle right here. And I found that one, again, because opposite angles are congruent. So I knew that this angle up here at K was congruent, right, to this angle down here at M. And then I said alternate interior angles because 880 is congruent to 80, right? I could do that as well. And then if I'm trying to find the other part, I would, well, yeah, I add them together, they equal, well, actually that one, yeah. I'd have to do the 60 first. Sorry, 60 was the one that we were given. So 60 is congruent with 60 because they're alternate interior angles. And then I would subtract the 60 from the 140 to get this 80 right here. Our last one is KOL. So KOL is this angle up here, and we're going to use the triangle sum theorem to find that one. So we're going to add the 60 to the 15, that's 75, and subtract that from 180, and that's how we got the 105. So, and I think we didn't have this 15 up here, sorry. So this 15 down here we would have put up there. Remember if I said when I did it that they're alternate interior angles. So that's how I would have got the 60 and the 15, and then add those together. All right, so our next one is a trapezoid. Now, what we need to recall about a trapezoid is that when we have a trapezoid has parallel bases, and the rule here to find the answer to this is add base plus base and divide it by 2 to get the midsegment. And the VW is the midsegment. So we're going to add our base plus our base, divide it by 2, and that equals our midsegment. So, because that's what VW is. So, sorry. So I added the two together, the two bases, and then I divided by 2. I set up that equation. Now, to get rid of a dividing by 2, I multiply by 2. So I'm going to multiply both sides by 2. That gets rid of the 2 over here on this left side, and it multiplies everything by 2 over here. When we do that, we're going to subtract 6x from 8x, add 22 to 10. Then we're going to divide both sides by 2, and that gives us x is equal to 16. Recall, though, that we have to plug that 16 back in to this equation right here to get the length of our midsegment. So we did 3 times 16 plus 5. That's 48 plus 5, which is 53. Okay, now we're going to go down here to part 3 for the kite. So the first thing I want to say about a kite is, by definition, a kite has a pair of consecutive sides that are congruent. So I know that these sides are congruent, and I know that these sides are congruent. I also know that EI, diagonal EI, from here to here, is being bisected as well by diagonal KT. So on this one, we're going to go ahead and put in our angle measures too. So it tells us that the angle down here is 40. And by the way, that means this would be 20 and this would be 20 if I actually asked you that. And then it says angle E is 130. So this angle over here is 130, which means its opposite angle is 130. And if you recall, all of these angles in here are right angles because those two lines are perpendicular. And then it tells, okay, we'll talk about the rest of it later. So let's go ahead and label XE is 9. So XE is 9 is here, and that means this has to be 9. KE is over here, 41, so that means this has to be 41. And I missed one, TE. Oh yeah, TE is 15 here, which means this has to be 15. All right, now let's talk about what we have here. So it's asking us for the measure of angle I. Well, that's got to be 130. And our reason for that would be because opposite angles that are between non-congruent sides are congruent. All right, let me pause and go to the other better written page. So now we have a prettier drawing with all the same measures on it. And it says that the measure of angle I, this angle over here, was 130 because angle E was 130. Opposite angles that are between non-congruent sides are congruent. So the measure of E is equal to the measure of I. You could have also said angle E is congruent with angle I. Then we're asked about measure of angle T. Angle T. is down here. Now the way we would get that is, remember, the sum of all these angles added together has to be 360 degrees because the sum of angles in a quadrilateral is 360. So we're just going to basically add up all that we have and set it equal to 360. And when we do that, we're going to get 40 plus 130 plus the measure of angle t is plus 130 is equal to 360. When we do that, we get that it's 60 degrees down here. All right, then our next one, the measure of xi. Again, kxi is 90 because all of those angles in there are 90 because those two lines are perpendicular. Kt and ie are perpendicular. Then this is ix. Ix here was 9. Ik up here, remember that ix was congruent with ex, and then ki was congruent with ke. It was congruent with et. Those are because consecutive sides. Up here is because the diagonals between non-congruent sides of a kite are bisected by the other diagonal. Here, consecutive sides in a kite are congruent, consecutive sides in a kite are congruent. And then we talk about xt down here. Xt is the one that we don't have. It's the only measure that we don't have right now in this drawing. Actually, we don't have this one down here or this one up here. And the way we'd find both of them is by noticing that this is a right triangle right here, and that's a right triangle up there. So xt here, we would say that a squared plus b squared equals c squared. So we've got our 9 squared plus xt squared is equal to 15 squared. So that would be 81 plus xt squared is equal to 225. We're going to subtract 81 from both sides, get 144. So that means this measure right here will end up being 12. Now we could have also solved for this measure up here, same way. A squared plus b squared equals c squared.